Hello, my name is Kendra Albert,
And I'm Maggie Delano.
and we're here to present our paper, This Whole Thing Smacks of Gender, Algorithmic Exclusion in Bioimpedance-based Body Composition Analysis. Our story begins when I wanted to use a Withing SMART scale, specifically this Withing SMART scale, to calculate my body fat percentage. Here it is, looking slightly menacing. I decided that this was the thing I wanted to do and very quickly ran into a roadblock. It only has two options for gender, pants wearing and skirt wearing. This is a disaffordance for non-binary people like me. It basically means that I can't enter the right option for gender here. It's just not a thing I can do. The app won't let me. So being difficult to describe my gender as either pants wearing or skirt wearing, I asked Maggie to sort of pick one and not tell me what it was. And thus began a long odyssey in using the SMART scale. So when you pick skirt wearing, and I stand on this scale, we get X body fat percentage. But when you swap it to pants wearing, I got X minus 10 body fat percentage. So it went down from, let's say 30% to 20%. Now, between those two moments, I had maybe taken off my socks, but I had not sort of changed my body fat percentage in any meaningful way. So that was really odd. Why would my gender, or the gender that is, it's not my gender, the gender that I enter here, make such a difference to my body fat percentage? Well, it turns out that to answer this question, like which one should I pick and why does this happen, we had to dive deep into the bioimpedance analysis literature, and Maggie's going to tell you about that.
Okay, so I'm going to tell you about some assumptions of bioelectrical impedance analysis, which is the technology and algorithms that are used inside commercial weight scales like the Withing scale. So first of all, what is BIA? Bioelectrical impedance analysis. Bioimpedance itself involves measuring the electrical properties of tissue by driving a small painless current through the body. So your body is actually made of primarily conductive fluid. And so you can measure the volume of that fluid in a way that I'll show you on the next slide, and then use that to actually estimate body fat percentage, because fat itself is not conductive. So in practice, the way BIA works is that it uses demographic and anthropometric information, such as your age, weight, height, sex / gender / question mark, etc., along with the bioimpedance itself to fit to a model to estimate your body fat percentage. So if we want to kind of start and think about how BIA works, the first thing that we consider is a little bit of theory, which is that the resistance of a conductive cylinder with the resistivity rho, a cross-sectional area A, and a length L, in this case L is the height of the body, is equal to rho L over A, so the top equation on the right there. And then if you take if you take that equation and multiply it by L over L, so unity, you get rho L squared over volume, if we assume that the volume of the cylinder is equal to A times L. If we move some equations around, we can then get volume equals rho L squared over R. So now, if using this, if we measured your bioimpedance and we assume that you were a cylinder, then you can get the volume of the actual conducting tissues. This is called the total body water. So we have to take a couple extra steps to go from the volume that we've measured of you to the actual body fat percentage. So the next steps here is that we say that we multiply the volume by the density of your body, so that will give us mass. But then we also have to consider that there are other parts of your body that make up what's called the fat-free mass, or FFM, on the left side of the equation there, that aren't water. So we also have to consider the fraction of fluid, which is basically how hydrated you are. So you can already see that these are additional assumptions. So what's the density of your body, and then how hydrated are you? So once we have the fat-free mass, we can calculate the fat mass, which is FM. So the fat mass is equal to weight minus the fat-free mass. So the key thing here is basically we're assuming that the body either has fat mass or fat-free mass. So it's called a two-compartment model. So then if we have the fat mass and the fat-free mass, we can calculate your body fat percentage, which is the amount of fat mass that you have divided by your total weight, which is your fat mass plus your fat-free mass, times 100, which will basically make that into a percentage. So practically speaking, of course, you are not a cylinder, and we don't necessarily know D body or F fluid. And so what a lot of weight scales do is that they actually use a linear regression instead of trying to calculate it based on this sort of theoretical model. So this is what an example BIA equation might look like to calculate fat-free mass. And the important thing with linear regression is to consider the terms. So if we see h squared over r, weight, X, which stands for the reactants, and then sex. And so these variables are basically all being used to kind of get a close enough estimation for an individual person based on the results for many different people, where for many different people, they measured the bioimpedance, which includes the resistance R and the reactance of the bioimpedance X, their height, their weight, and then their sex/gender. And so you put all these things together, and then you get some sort of estimation of that person's fat-free mass. And in this case, sex basically stands in for a constant. So if you are put in as a man, you have 4.229 kilograms more fat-free mass than a woman. And the slippage between sex and gender here, so basically saying sex, but then using the word men and women, is very common in this literature, and we'll talk much more about that in much more detail later in the presentation. So I'm going to turn it over now to Kendra to talk more about critically analyzing the BIA literature.
So what's wrong with the BIA literature? Maggie's laid out that there are a lot of assumptions. We already know that humans are maybe not necessarily cylinders, but there's some other stuff going on here that's worth noting. So it would seem like the sort of starting solution to the why things problem that I established at the beginning, the way in which I wasn't really sure which option to pick when confronted with pants wearing or skirt wearing, would be to just change the gender term on this profile to sex, right? Everybody has an option between pants wearing and skirt wearing in terms of sex. Well, it turns out that it's way more complicated than that. Once you started to look at how sex is used in the BIA literature, there's a lot to unpack, mostly because sex is doing way too much, right? So we start with the premise that biological sex is not a coherent category, and I'll come back to that and talk about why we start with that assumption in a second. But that's because there's a variety of part of why we do that is because there's a variety of different sexual characteristics that are sort of rounded up to one idea of sex. It's unclear which of these sexual characteristics are even relevant to body fat percentage estimation. For example, oftentimes we think of sex as assigned female at birth or assigned male at birth, but what those mean really has to do with the genital erectile tissue of a certain size at birth, right? And how big your genital erectile tissue is at birth probably has nothing to do with, or very little to do with, your fat percentage when you're an adult. It may be that that's a proxy for the amount of testosterone you have, but that also may differ from sort of assigned male at birth, as any trans person who's been on hormone replacement or hormone treatment may have different sort of testosterone or estrogen levels than one would expect based on their gender assigned at birth. It's also unclear how sex was evaluated in the research papers used to construct BIA algorithms. So Maggie already talked about the slippage, right, between sex and gender. It's like a little unclear which they're talking about. But when they say gender or sex, they don't talk about how they gather that information. And some of these studies are really big, right? So we're talking about 5,000 participants that were recruited at the German equivalent of a county fair. And so it's actually statistically unlikely that none of those participants were transgender or potentially intersex in ways that might matter for this. Unless those people were specifically excluded. And if they weren't specifically excluded, we don't know how they were coded as part of that data. So we really don't actually know even what sex is supposed to be doing. Finally, sex and gender are not sort of these nice discrete categories. If you have sort of internalized your sex and gender theory from the genderbread person exclusively, I hesitate to inform you that sex is also sort of socially constructed and influenced by gender. So there are ways in which, even once we think about the sexual characteristics, they may be influenced by gender and by social phenomena. And all of this draws on sort of a broad array of literature that we cite in the paper, including the sort of biosocial work of Shattuck, Heyerden, and Richardson, sort of the work on intersex and social construction of sex from Georgia M. Davis and Sharon Preeves, and then Anne Fausta Sterling's sort of theoretical work on sexing the body, as well as sort of activists who have produced documents like the Fallometer, which is meant to illustrate how sort of the concept of sex is socially constructed and not any more rooted in clear categories than gender ever was. But the problems with sex/gender are sort of just the tip of this problem, of the problems with these studies. And this is most obviously illustrated by Kyle et al.'s roundup of studies from 2001, where they look at 26 different studies. I'm sorry, it's from 2004. They looked at 26 different studies that produced these equations for fat-free mass calculation. And what they found, actually, it's not even what they found, it's just an aside, that 23 of these studies were actually only, that produced equations were, the only participants were Caucasian. Only 3 of the studies included what they call ethnically diverse populations, although once you read the actual information, it's not entirely clear that they were ethnically diverse, they just were not white. So that is to say that because race and ethnicity, in the same ways as sex and gender, having impacts on people's lives can impact their body fat percentage, and that they are there are ways in which the social impacts of those categories are felt on the body. We actually do know that using Caucasian or white folks as a default and sort of pushing those assumptions across everyone who might use these technologies is not going to lead to accurate predictions, or is going to lead to less accurate predictions for folks who aren't white. So once we sort of unpack the sex bit, what we actually discover is there's sort of this iceberg of algorithmic exclusion, where the disaffordance for non-binary people upon opening the app is, only the tip, right? And then the potential exclusion of all folks of color who aren't going to get accurate readings, white fat people, white elderly people, and white people whose sex characteristics don't match their gender, aka sometimes trans folks or intersex folks. All of those folks are actually also not going to be able to use this technology to sort of gain self-knowledge or an accurate prediction of their own bodies. You'll note that there were asterisks on that slide. That's because we don't actually know how these algorithms work. They're, in the words of Ruha Benjamin, anti-black boxes. The algorithms don't have to be clinically validated, despite the sort of language around clinical testing that's often used, and the details of these algorithms aren't disclosed. So when we are talking about what we think these algorithms do, that's based on the underlying public BIA, or public as research papers are, paywalled BIA literature, rather than an understanding of what's particularly going on and why things, because we don't have access to that information. So we're going to talk a little bit about paths forward, but first of all, I want to suggest an anti-path forward, a thing that should not happen, which the sort of first assumption may be that the way to solve this problem involving gender is the way that many tech companies solve many problems involving gender, which is just to add the third non-binary option, here carefully illustrated as a half skirt, half pants wearing person. This is my own mock-up. Why things, if you're thinking about using this, you have to call me first. The problem is that this is just like a rainbow band-aid, right? It's not going to solve the underlying problem that this literature is not inclusive, that the BIA studies do not do a good enough job dealing with sex or gender to accurately make predictions with regards to non-binary folk, or to folks who do not fit into the sort of sex categories that are being used by the underlying literature, let alone with regards to sort of folks who aren't white. These kinds of rainbow band-aids are not going to effectively solve the problem. This issue can't be addressed by improvements to the UI alone. They need to be more fundamental. And Maggie will talk about how that will work.
Okay, so for some of these recommendations, I divided them into for manufacturers and researchers, basically separate, although of course these could both be the same groups of people. So the first one, which I think is probably the most challenging one, but also the most important, is to, when you're working on a project, to consider and choose the correct metrics. So choose metrics related to sex/gender that are appropriate for the specific project. So really taking time to interrogate which of these you are using, why you are using them, and then also relatedly assuming that there's a biosocial explanation for a lot of physiological differences unless evidence clearly suggests otherwise. And another important thing that can help, especially immediately in the future, is to acknowledge trans, non-binary, and intersex users, how their experience might be different from other users. So even if you can't necessarily address a lot of these issues, because it's going to take a lot more foundational research, we don't know what some better metrics related to sex and gender might be for improving the inclusivity of BIA just yet. At least acknowledging that these people exist and how they can interface or use what you have learned so far would be really helpful. And similarly, analyzing and disclosing the results for subgroups in an individual level can also help improve the algorithms, even if nothing else changes. In particular, we looked at a lot of different studies, and basically the main thing that they're reporting is just sort of the fit error in aggregate across all people, but then really taking time to analyze the results for subgroups, and then also at the individual level can see where there might be some sort of algorithmic discrimination happening and opportunities to help improve the experience for specific people. In terms of recommendations specifically for manufacturers, explicitly state the precision of the measurement system along with the assumptions and constants used. So when I see the value 30% body fat percentage, is that 30 plus or minus 5%? I should really know how precise this is. Withings often, when they see critique, has basically said, you should really just track this number over time and compare it to itself. You shouldn't assume that it's an absolute accurate number. I think it should be more clear that that's true. And if these numbers aren't real, then maybe you should use a different number or some other way to convey the information. And the other recommendation is to use clear terminology based on the underlying research or known physiology to select a term for sex gender, and especially don't use pictograms, so no skirt wearing, pants wearing. Be very precise about what you're using and why you're using it, so that way a non-binary or trans or intersex user can say, okay, based on what I know about my body, I can give the most useful information to the device. And also for researchers, don't assume that the gold standard has no assumptions of its own. So when we talk about a gold standard, I basically say these equations came from comparing the results from the BIA system with all the different equations to some sort of reference metric of like, what's the reference, the gold standard for body fat percentage. In this case, many times it's often used as DEXA. But some of the technologies that are used actually have some of the same assumptions that BIA makes. So they make assumptions about the density of body fat, for example. If you make the same assumptions, the gold standard isn't actually really a gold standard anymore. So really understanding the assumptions and then evaluating them and discussing how they might influence the results is really important. And then also explicitly stating how sex and gender are being used and what they stand in for. So sex is often used as a stand-in for the dimorphic distribution of body fat in the human population. I think it's important to talk about the fact that, there is some distribution of body fat based on many, many different parameters. And the researchers have chosen to divide that into two and take an average. And that's what they're calling sex, and that's how they're using sex. And be clear that that's more a descriptive thing than necessarily a biological fact that there are two different sexes. Okay, so those are some of our recommendations, and I'll kind of turn it over to Kendra now to wrap things up.
So over the course of this presentation, we've taken you on the journey with us, going from just being really confused by how to deal with pants wearing to skirt wearing in terms of the scale, to learning how BIA equations encode sex or gender as sort of this like binary, as both a binary and sort of just a plus minus. Then looking at how actually the lack of biological sex being a coherent category and the assumptions are just a broader set of assumptions made by the bioimpedance literature that is being used to calculate this fat-free mass, and thus this body fat percentage number that Withings uses. We finally conclude by just saying, like, just adding another gender category is not going to work here, right? That no rainbow band-aids. You need to actually change the underlying systems and consider the ways in which sex and gender are sort of interacting, and how gender is actually driving the whole bus when it comes to analyzing these numbers, and how that isn't going to get fixed by just changing one option or two. It requires reimagining much of the entire field in order to include non-binary people, trans folks, and some intersex folks more accurately. Thank you.